Okay, so second half of 5.4, maybe start off by, just for review, doing this first question, and then we'll go through it together. This will be like warm-up. The second half of 5.4. Oh, I don't think it's in your workbook. Yeah. Paper cut. This is a very dangerous job. I'm shocked at how much this happens. I'm embarrassed to go to the office because I went to them yesterday for the same thing. They're gonna wonder what's wrong. I have a Band-Aid. Oh, do you, Karis? I would appreciate that. Thank you, because it's actually pretty bad. Somewhere. Thanks, Everin. You guys are the best. It's a little old, but still Thank you.
My mom manages to cut herself all the time. I don't know how. Like every time she's in the kitchen, she cuts herself.
Oh, funny. That's how the first one happened. That's what happens when I try cooking. It's actually 2 fingers, everybody. What do I do? And now it's, and the other one was this finger, so it's now 3.
Oh. Do the math, dude.
Thank you. Are we okay to move on? Okay. I'm going to try to talk you through the things to look for because I'm hearing that a lot, that you're having troubles figuring out like where to go with it. And through all those different rules that we looked at, you have a lot of choices. It's symbolic of the times that we're in. Isn't that like our biggest issue these days? Like whether it's Netflix or whatever it is, like there's so much you don't know what to do with it. So here are the things to look for. Notice how this and this have the same base. So this, if we're going to rate these, this is actually one of the easier ones, or not quite as challenging, because it makes life harder for us when the base is not the same. And that's when we have to use some of those, like the change of base rule or whatever else to help us to change the base. So in this situation, what are we allowed to do? I can just ignore the left side for a minute. I'm going to leave it off to the side. But if the base is the same and I'm adding these two logarithms, what are we allowed to do with them? Yeah, we can multiply these. So we can say log base 2 of x plus 2 times x. And then we can just go ahead and simplify that. Log base 2 of, when we distribute this here and here, we just get x squared. I should put it in brackets because the whole thing is a part of the logarithm. Do you see, like, it's such nitpicky little stuff, but if I don't have the brackets there, do you see that it looks like it's just this part with the log? So that is actually quite important. And then you look at it and analyze and think, if my goal is to get x by itself, I can't really do that if it's a part of a logarithm, right? So what will allow me to take it out of log form? Yeah, we can switch it to exponential form. And the reason that I know that that's a smart thing for us to do is when I look at the base and what it's equal to, they're both whole numbers. So I know that when I switch it to exponential form, it'll allow the x's to be like easy to work with. So when I do switch it, what's going to be the base in my exponential form? The base will be 2. What's going to be the exponent? Yeah, remember we swapped the other two, so it's going to be to the power of 3, and that's all going to be x squared plus 2x. That didn't end up very nice. Now I don't actually need the bracket, so are we okay with doing that so far? Yes.
I got to that point.
Yes.
By accident.
Okay.
I don't know how, because I was like, oh, how can I put a log into that 3 to get rid of the logs on both sides? And I'm pretty sure this is wrong, but I just put log 2 to the power of 3. And no, wouldn't equal to 3, but somehow I got the right answer.
You can, because log 2 to the 2 is just the number 1. So that's just 1 times 3. So yes, does everybody get what Karis is saying? You can do that.
Oh.
Yeah. Yeah, so go ahead. So I'll just do that off to the side. If we have something like log base 2 of 2, do you see that's just the number 1? Yeah, so we're allowed to throw that in, and you could have log base 2 to the 2 to the power of 3, or that could just be multiplied by 3. So that's another way that we could approach it. Good? Yes?
It is a similar thing, but instead I turn it to log base 2 of 8, and then I do log.
Oh, yeah, you can do that. So again, there's going to be multiple ways as long as you're following the rules of math and you're not actually changing the number or the value overall, then it's fine. Good? Okay, so we would get x squared plus 2x minus 8 equals 0. Again, do you sort of see the pattern of, like, we've been in this position before. We were wanting to get x by itself, so we just go ahead and factor this. 2 numbers and multiply to this and add to this. So we would have x plus 4 and x minus 2, because we want it to end up positive. And from that, x must be negative 4 or 2. Always when we get to the answer, we compare it to the original. And let's take a look at, I had said last day to list off the restrictions right at the start, and then I didn't do it here. But what are the restrictions here? X here must be greater than negative 2, and x must be greater than 0, right? So right off the bat, I can reject this. Reject negatives. Good? We're still not done because we should still take that, and it said verify. So this is us verifying that our solution is correct. So we could do 3 equals log base 2 whoops, it covered the equation. Log base 2 of 2 plus 2 plus log base 2 of 2. So just to make this clear, this 2 is what we've plugged in here and here. And so if this is just going to be log base 2 of 4, which is what? Yeah, this is like saying 2 to the power of what is 4. Do you see it's just the number 2? Are we pretty okay in thinking in terms of logs now? We're getting better at that. Plus log base 2 of 2, we just talked about that. This is the same thing as the number 1. So we just proved that this is in fact true. So therefore, we can say x equals 2 is our overall solution. Questions? Okay, solve for A in terms of B and C. Do you want to take a minute and then we'll go through it, or do you want to just go through it together? Take a minute. Go through it. Oh, we have mixed. Yeah. If you want to wait, you can just wait, but I'll give everyone just a minute. Basically, it's telling, if it says solve for A, another way of saying that, just get A by itself, right? Do you see that it's actually a lot like the last question we did, but instead of numbers, we're simply dealing with all these variables, but we're still doing the same thing. You want to unwind this and look for ways to get A by itself. Are we okay to move on? Okay. I'm going to talk you through the things to look for. I think that's the part that's going to be most helpful. And also, I'll say this. It's very likely that you did this differently, and there's different ways of doing it, and that's totally fine. I'm going to try to simplify it and make this nice and clear for you. But if it says solve for A, well, A right now is in a logarithm. And it's not like I can't just separate it from log, right? And then this part is also a part of a logarithm. So if I am wanting to get A by itself, I would want to try to see if I can get rid of the logarithms. Does that make sense? How I know to do that, or that that's my goal, is the fact that it's it's stuck together as one unit, and I'm not able to just get a by itself when that's the case. So I know that I eventually want to convert it into exponential form. Good? The way to do that is I want to try to like simplify and shrink things down in an attempt to try to get there. So to start off with, do you see that if I am going to get rid of this for a second, and I want to try to simplify things here for a minute. Simplifying when you have two different logarithms, but they have the same base, what's a way that we could simplify those? What is this the same thing as?
2 log A over B.
A over B. Everybody good with that so far? The reason that I thought to do that is because if I just have the one logarithm and I switch it into exponential form, that should allow me to just get rid of, like take it out of log form, which makes it easier for us to work with. So this is the thought process. I'm talking you through it all because those are things that you should also be looking for. When you look at a question, you're trying to figure out, like, where do I even go with this, right? So it's because I know I'm trying to get A by itself. Okay, do you see that that's, sorry, maybe before doing this, I should have done this first. Do you see that I could have brought that up to say A squared first? The reverse of the power rule, right? So it's the same thing as log, just the A is squared at the top over B. And then if I did want to change this into exponential form, what does it look like? Yeah, thank you, Ian. So the base here is 10. So I would keep the base the same. If it doesn't say anything, we know the base is 10. This becomes the exponent, and then it's equal to A squared over B. This is now looking like our old school algebra questions. Like, I'm trying to think of what grade, maybe grade 9 or 10.
Old school.
Old school.
Yeah, years ago. Well, I guess for some of you, is that only last year? 2 years ago, yeah. So, but a lot's happened since then. Like logarithms took up a lot of space, right? I get that. Okay, so where do I go from here? I'm just trying to get A by itself. Yeah, multiply both sides by B, so that's going to bring this up here. So I could say 10 to the C times B equals A squared, but I want just A, so do you see that I could square root it? So it looks... Good. What would be the best way to write it? Root B 10 to the C? Yes. We don't have to write the plus or minus because it's when, if we knew what B was equal to and C was equal to, at that point we would take the, but technically yes it is, anytime we have a root. Good?
Would it actually be 10 to the power of C times B?
Yes.
Wouldn't that be the right way to write it instead of B 10 to C?
Well, so usually coefficients are a number. That's the reason why you'll see this written different ways, but the way that I look at it, the coefficient is usually a number. The only weird thing about this is that it has an exponent on it, and usually we put the exponent part second, so it doesn't really matter, but I feel this, I mean, it's weird any way that you do it, but I think that this one makes the most sense to me. Either one would be right. Good? So far, so good? Questions? I get this. The part that you're struggling with is looking at it and figuring out what to do to start it. So that's the part I'm trying to talk you through in the hopes that you'll start to pick up on some of those patterns and it'll become easier. Give that a try. We'll go through it together. I've purposely chosen some that are a little bit intense, but I think it's better that we go through that together. This is like weightlifting for your brain. Do you feel it? Look, this from a paper cut. Isn't that awful? Let's go through it together. Anybody still want a minute? Okay. Okay. This is an exponential. Okay, I think that it helps to look at this, like step back and look at the big picture. If you look at the big picture, what type of equation is this? It's exponential, right? It just so, I know I just said it. It just so happens to have log in the exponent, but it is an exponential. It's in exponential form right now, right? When that happens, if we're trying to solve and figure out x, I know for sure that I absolutely have to get that down from up there in the exponents. So, and there's actually, like, this is complicated because there's an x here, there's an x there, and one there. This is a bad one. But I think it's good that we go through it together and I talk you through the things to look for and the strategies to use. So we need to get the log down from the exponent. So let's change this into log form. If I change this into log form, what's the base of my logarithm? Okay, that's not nice, but okay. It's still, yeah, it's gross, but that's all right. Log x, and what are we taking the log of? 100x, and what is that equal to? Log x. So to make it clear, that came from up there. That came from there. And then we already know the other part. I'm out of colors. That one is just that one. Good? Okay, so now the other part that's making this especially confusing or difficult to work with is that there's an x in the base of the logarithm. And on the other side, there's a logarithm, but the base is 10. So can you think of a way, like remember what we're always using to guide us through these? We're trying to look for similarities. If there are none, so you can see right now there are, well, not that there are none, but the bases are different, then we can start to apply our rules to change it, to create similarities. So how am I able to rewrite this part? Everin? Log 100x over log x. Everybody agree that that's allowed? And see which rule that comes from? Right? So we can take this complicated logarithm with a base of x, and we can rewrite it by separating that and that into this form here. So far, so good? So believe it or not, it's getting a little bit better because now at least the base is 10 in all of them, right? If our goal is to get x by itself, any idea how to get to that? So right now this is still pretty confusing or pretty messy because I have a fraction with log 100x at the top, log x at the bottom. What could we do? Isaac? Pardon? D-log? Oh, can we right now? Let's say this wasn't here. Then we could. So I'm glad you brought that up because it's important that we talk about that, but it is there. So we actually can't right now. Multiply both sides by log x because at least that will allow us to, so we're going to get rid of that. At least that will allow us to do log 100x equals, what is log x times log x? We only once briefly looked at how to write that. Log squared x. This implies that the whole thing is being squared. So it's log x times log x. Yes?
There's no really way to multiply them, right? That's what I was told.
Multiply log x times log x?
Logarithms, multiply them together, there's no really effective way of doing that.
No, the only way, like, so if we knew what the x was, which value it was, we would find, like, let's say it was log 7. We would punch in, like, we could find log 7 and multiply it by log 7, and that's what this is implying. Yeah. Okay, so we kind of know this again from something similar. I keep referring back to polynomials. Do you see how this is kind of resembling polynomials? Let's forget the logs. Let's pretend it was like x squared, and then on the other side we had 100x. If you have something with x squared and then something x, and then just some number, how do we usually solve that?
Factor out the
We factor it out, right? So it's still the same thing, but it happens to be with logarithms. So I can subtract this to get it to the other side. So I'm going to say log squared x minus log of 100x. Whoops, that doesn't look right. Does everybody see what I just did there? Okay, yeah, let's do that. So over here, can we separate these? What's another way I could write that? Oh, okay. Wait, before we do that though, we'd have to separate log 100 and x. Thinking backwards from our rules, how do I rewrite that?
log 100
Log 100 plus
plus log x.
log x. Does everybody see that that's the same thing? So that this and this mean exactly the same thing. We're just going backwards in our rules. And then somebody else called out that this is just the number 2. Are we all good with that? So now, okay, so now we'll take it to the other side. Log squared x minus log x. So do you see that I'm just taking this and moving it to the other side? And then it must be minus 2 to get it to the other side. So far, so good? Want to ask me anything? Anybody unclear on how I got that or where it's coming from? Do you see what I mean? That it resembles what we've done with polynomials? So then off to the side here, I mean, we could just factor it this way, but it's already ugly enough as it is. Let's substitute in m equals log x. And you don't have to do this. I just think that this makes it easier for people to be able to see what's going on and takes the confusion out of it. Do you see we would have m squared minus m minus 2? We're just doing this as a step along the way to make this a little easier for us to see. And if that's all I had, how would I factor that? M minus 2 and m plus 1. Everybody good with that? This is what I mean by it's the same old rules or the same stuff that comes up, but it happens to be with logarithms, which is intense, I'm admitting. And then we need to substitute that back in for m. So we only use this as a step along the way so that we could get some clarity with what's going on, but we would say log x minus 2 times log x plus 1. Questions? We're all clear on how we got that to the factored form. All this m stuff, you don't have to do that. If you are able to look at that, look at this and easily factor it, go for it. This is just something I'm using to simplify and clearly show you how we factor something that looks like that. Okay, and then do you see that these separately I would want to set equal to 0? So when I set it equal to 0, I would get 2 equals log x, and I'd want to go through and solve that. And here I'd get log x equals negative 1, right? Just how we normally solve this. And we're basically, because this was our goal all along, we're using this to find a number or a value for x. I'm not really able to do that right now, but what could I do to get x? What's the base here? 10. So x is equal to 10 to the power of 2. when we change it to exponential form. Are we good with that? So from this, we just found 100 is x. Same idea here. 10 to the negative 1 is equal to x, right? Where we switch it to exponential form. And 10 to the negative 1 is the same thing as 1 over 10 is equal to x, which is what we get here. Are we done? What would we have to do? We'd have to check both, but I feel like who has time for that right now? You am I right? You both you all know how to take both of those, plug them back into the equation and double check that they do in fact work. Wow, I think we'll call it a day. Page 228, 2, 3, 6, and 8. Remember what I said to you? You decide how much of that you want or need to do. And I'm also going to give you a worksheet to practice the different types.